Assalamu alaikum dear students. In the last lecture of chapter 4, Laws of Motion, we had studied about collisions. As during collisions a number of objects come together, interact, that means exert forces on each other and scatter in different directions. Now during the collision, the linear momentum of the entire system of the particles is always conserved, as there is no external force acting on the system of particles. So here we can say that the total initial momentum of the system is equal to total final momentum of the system. That means the total momentum before the collision is equal to total momentum after the collision. However, the kinetic energy of the entire system may or may not be conserved. So, the collisions can be divided into two types: elastic and inelastic collisions. A collision is said to be elastic if kinetic energy of the entire system is conserved during the collision along with the linear momentum. That means when the total kinetic energy before the collision is equal to total kinetic energy after the collision, as well as the total linear momentum before the collision is equal to total linear momentum after the collision. So, such collision is said to be an elastic collision. So, in the elastic collision, there is a conservation of linear momentum as well as there is a conservation of kinetic energy is there. And hence, we can write the total initial kinetic energy is equal to total final kinetic energy, with total initial linear momentum is equal to total final linear momentum. So, in the elastic collision, two conditions must be satisfied: conservation of linear momentum and conservation of kinetic energy. A collision is said to be inelastic if there is a loss in kinetic energy during the collision takes place, but the linear momentum is conserved. In the inelastic collision, there will be the conservation of linear momentum takes place, but the kinetic energy may not be conserved. The kinetic energy before the collision is different than the kinetic energy after the collision. The loss in the kinetic energy is either due to internal friction or vibrational motion of atoms causing heating effect. Thus, during an inelastic collision, the total initial kinetic energy is greater than total final kinetic energy. And during an explosion, as energy is supplied internally, then the total final kinetic energy is greater than total initial kinetic energy. But in both the cases, the conservation of linear momentum will take place. That means the total initial linear momentum is equal to total final linear momentum. And the difference between the kinetic energy which appears in the inelastic collision is converted into another form of energy like heat energy, sound energy or deformation, etc. So, in the inelastic collision, there will be only conservation of linear momentum there. The kinetic energy of the system is not conserved. The total initial kinetic energy is differ than the total final kinetic energy. Then the special case of the inelastic collision is said to be a perfectly inelastic collision if the bodies after the collision join together and move with the same final velocity, then it is said to be a perfectly inelastic collision. Energy is either due to the internal friction or vibrational motion of the atoms causing heating effect. Thus, During an inelastic collision, the total initial kinetic energy is greater than total final kinetic energy. As here the kinetic energies before and after the collision is not same. Before the collision, the total kinetic energy is greater than the total kinetic energy after the collision. Hence, we can say that there is a difference between the kinetic energy before and after the collision, and that difference occurs actually, it is to be converted into some another form of energy there. And during an explosion, an energy is supplied internally, thus over there the total final kinetic energy we are getting greater than the total initial kinetic energy of the system there. So, as stated earlier, the total initial momentum is equal to total final momentum for inelastic collision or explosion also. That means, if the inelastic collision will be takes place, the total linear momentum is conserved. The total linear momentum of the colliding particles, or if the explosion will takes place, the total linear momentum before and after the collision will be same, but their kinetic energy will not be same there, as there will be the difference between the total initial and total final kinetic energy of the system before and after the collision over there. So, here the difference that we are getting in the inelastic collision, that means the kinetic energy is not conserved in the inelastic collision, only momenta is conserved over there. So, that difference in the kinetic energy will appear in some amount of, you can see, it is to be converted into like heat energy, it is to be converted into the light energy or deformation, etc. That means the difference that we are getting in the kinetic energy before and after the collision in the inelastic collision, that is to be converted into some other form of energy. For example, if we are throwing a ball from a certain height, for example, from the ground surface, we had taken the height 2 meter. So, from the 2 meter, we are just freely fall the ball, and when it will strike to the ground. So, you will observe that after striking with the ground, that means the ball is making collision with the ground there. And after making the collision, the ball will not retain the same height, that is 2 meter. It is always below the 2 meter. So, here we can say that the initial kinetic energy is greater than the final kinetic energy. After the collision, the kinetic energy will be reduced there, and that kinetic energy which is to be reduced, it is to be appear as in the form of the sound energy. As the ball is to be strike with the ground, the sound is to be appear over there. So, here we can say that the kinetic energy which is to be reduced after the collision, it is converted into the sound energy there. So, such collision is said to be the inelastic collision. So, over here in the inelastic collision, the total linear momentum of the body is conserved, but kinetic energy is not conserved there. The total initial kinetic energy is not equal to total final kinetic energy. So, this is all about the types of the collision, elastic and inelastic collision. Now, next let's have the perfectly inelastic collision. As this is the special case of the inelastic collision, we come to know that in the inelastic collision, the total linear momentum of the body is conserved, but kinetic energy of the entire system is not conserved there. If colliding bodies join together after the collision, then it is said to be a perfectly inelastic collision. Here we can say that the perfectly inelastic collision is actually a special case of the inelastic collision, and in this perfectly inelastic collision, what happens actually, the colliding bodies join together after the collision and they are traveling with the same velocity together after the collision, and such collision is said to be a perfectly inelastic collision. In other words, the colliding bodies have a common final velocity, we can say, after a perfectly inelastic collision there. Being an inelastic collision, obviously there is a loss in kinetic energy of the system during a perfectly inelastic collision. In fact, the loss in kinetic energy is maximum in perfectly inelastic. As for the perfectly inelastic collision, the colliding bodies after the collision moving with the same velocity. That's why the difference between the final velocity, which is also called as the relative velocity of separation, is 0, and hence the coefficient of restitution, we are getting the value as 0. So, if the value of E is 0, then we can say that the head-on collision is perfectly inelastic collision. Now, next let's determine the coefficient of restitution during a head-on elastic collision there. That means here we are going to determine what will be the value of E if the collision is said to be a elastic collision. It is perfectly inelastic collision. What we had seen over here, that we are considering a bullet fired towards a block. Block is to be kept on the smooth surface. Now, when the collision is to be made between the bullet and the block, and the collision is said to be the elastic if the bullet rebounds with the exactly same initial speed and the block will remain as it is. But if the bullet gets embedded into the block, then bullet and the block will move together jointly with the same final velocity, and hence it is said to be a perfectly inelastic collision. Now, if the bullet rebounds with the smaller speed and comes out of the block on the other side with the same speed, then it is said to be the inelastic collision. Now, there is nothing called a partially elastic collision. We cannot say it is the partially elastic collision. We have to remember that either it is the inelastic collision or elastic collision or perfectly inelastic collision. We cannot use the term partially over there. So, if the bullet rebounds with the exactly same initial speed and block remains stationary, then the collision is elastic collision. And if the bullet is come out of the block over there on the other side with the little bit smaller speed or the same speed, then it is said to be the inelastic collision. And if the bullet is embedded into the block and bullet and block is moving with the same final velocity, then it is said to be the perfectly inelastic collision. Now, let's have the next example. As already we have discussed, that visualize a ball dropped from some height on a hard surface, the entire system being in an evacuated space. If the ball rebounds exactly to the same height from where it is dropped, the collision between the ball and the surface is elastic. As you know, the ball never reaches the same initial height or a height greater than the initial height. So, rebounding to a smaller height refers to the inelastic collision. Instead of a ball, if mud or clay is dropped, it sticks to the surface, and this is the perfectly inelastic collision. So, here we had discussed the examples of the elastic and inelastic and also the perfectly inelastic collision. So, here we have discussed work done by a variable force and elastic and inelastic collisions. The chapter will be continued next time in the next lecture. Thank you. Thus, for an elastic collision, the coefficient of restitution E is 1, and for a perfectly inelastic collision, the coefficient of restitution E is 0. Thus, for any collision, we can say the coefficient of restitution lies between 1 and 0. So, here we have discussed about coefficient of restitution. The chapter will be continued next time in the next lecture. Thank you.